Hey guys, it's me ActiveXploit back again with a new video on the malware development series, and in today's video we're going to be having a look at how to create a reverse shell using C. Also, if you haven't checked out the previous video of the series, which covers basic socket programming, which contains server-side and client-side programming, do make sure to watch it. And if I talk about the development lab part, I have my Kali Linux machine over here, and I have my Windows VM over here where I'll be actually programming the reverse shell. So, with that being said, let's get started. Okay, so I have my Windows VM over here, and I'll be using Sublime Text as my code editing software today. And once again, I would actually like to say that if you are not really familiar with socket programming, please do make sure to check the previous video of the series, which covers some basic socket programming. All right. So with that being said, let's actually start out by importing some of the necessary libraries, which we are going to need. So first of all, we'll include these winsock 2.h library. So winsock 2.h. We then need the standard input output library, and we also require the Windows API library. Whoops, windows.h. And now I'll be creating a main function. So int main, and now we'll actually declare a socket structure. So we'll just say socket, and the name which I would like to give to this structure, it can be shell. Okay, socket shell. And next we'll actually declare the sock adder underscore in structure, which is actually required, and it actually holds some necessary information which is used by the connect function or the bind function. Okay, so we'll just say sock adder underscore in, and the name which I would like to give is shell underscore adder. And then we simply specify the WSA data structure. So WSA data, and I'll just leave it as WSA. And finally, we'll actually create a string which holds our IP address to connect to. So I'll just say char IP adder equals to the IP address, which is I actually forgot my Kali Linux IP address. So as you can see, the IP address is 192.168.1.3. So I can just go back and I'll just put the IP address over here. So 192.168.1.3. And now I can declare a variable which actually holds the port to connect to. Okay, the port number. So I'll just say int port equals to 8081. So we'll be connecting on the port 8081. So now we can actually start the main part where we actually connect to the server, and we simply spawn a shell. So now what I'll do is I'll actually say shell equals to WSA socket. Okay, and the first argument which you actually pass to this function is the socket type which you want. Okay, not the socket type, but you actually specify if you want to use IP version 4 or if you want to use IP version 6. So we are going to use IP version 4, so I'll just say AF underscore inet, and then we simply specify the type of the socket which we want to create, which is going to be TCP socket. So I'll just say sock underscore stream, and I'll also specify IP proto underscore TCP. And finally, the last three arguments, we actually just leave them as null. So I'll just say null unsigned int null, unsigned int null. Alright, so now this line is actually what we are trying to do is we are actually trying to create a TCP socket. So I'll actually leave up a comment over here saying create a TCP socket. And now what we can do is we can we actually have to first of all initialize winsock before creating any socket. So what we'll do is we'll just say WSA startup make word 2 comma 2, and finally we'll just pass the structure, the pointer to the WSA data structure. Okay, so if you wonder what this line is doing, is we are simply initializing winsock. Okay, and the winsock version which we are using over here is winsock version 2. So I'll just leave up a comment over here saying initialize winsock. And now we can finally specify some information for the sock adder underscore in structure. Okay, so we'll just say shell underscore adder dot syn underscore port, and we'll just specify the port number, the variable which contains the port, which is port over here. So I'll just say port, and then we specify the family type. So syn underscore family is going to be AF underscore inet, and finally we specify the address to connect to. So I'll just say send underscore it was adder, yep, it was adder dot s underscore adder equals to inet underscore adder, whoops, sorry for that, inet underscore adder, and we'll just specify the IP address over here. So IP underscore adder. Alright, so now we simply connect to the target server. So for that, what we'll do is we'll actually just declare a new variable over here saying int connection, and now we are going to use the WSA connect function. So we'll just say connection equals to WSA connect, and then first of all we specify the socket descriptor, which is shell over here. Okay, so we'll just say shell, and now we actually specify the pointer. Okay, we specify a pointer to the sock adder underscore in structure. So we'll just say sock adder star, and we'll just pass the address of the structure shell underscore adder, and finally we actually we have to pass the length of the structure. So we'll just say size of shell underscore adder, and the rest values, okay, we simply set them to null as we do not require them. So I'll just say null. Alright, also I'll be leaving a comment over here saying connect to the target server. Now we'll also add some programming logic over here saying if connect, okay, if connect is equals to socket underscore error, all we have to do is we simply are going to print out the error saying connection to the target server failed, please try again. Alright, and we'll just simply exit out of the program. And now I wanted to mention that if you actually look at these functions closely, you might find that they are not exactly the same which were used in the last video. Okay, but if you look at their syntax, it is exactly the same except the nulls which we are adding up over here. Also, if you still are having any sorts of issues in understanding what these functions are, you can simply go to Google, and you can simply just Google up something called the you can simply type up the function name. Okay, the function name which you want to understand. We can just say WSS socket. Okay, and then all you have to do is just add msdn at the end, and you should see the Microsoft documentation for that particular function. Okay, and you can read the whole documentation over here, and you can actually get the syntax of that function over here too. So if you still are having any sorts of problems understanding the functions, even after having a look at the Microsoft documentation, please do ask me in the comments, and I'll try to solve your issue over there. Alright, so far what we are doing over here is we simply are establishing a connection to our target server, and if the connection fails, okay, if the WSA connect function, if it returns something called socket underscore error, we are simply going to print out a statement which is basically going to be our error statement to notify the user. And after printing that error statement, we'll actually exit out of the program. So now what we'll do is we'll actually add an else statement over here, and now I'll actually declare an array to actually hold our data, the receiving data. Okay, so I'll just say char. Um, I'll just name this as recv server, and the size which I'll keep for this is going to be 512 bytes. Okay, and now I'll just go back down over here, and now what we are going to do is we are going to use the recv function. So recv function, as the name suggests, it does nothing but just it simply receives for data, okay, from the server. So we'll just say recv, and the first argument to pass to this function is the socket descriptor. So the socket descriptor is shell, and the second argument which we actually pass to this to the function is the container which you want to hold the data in, which is basically going to be recv server over here. So I'll just say recv server, and then you simply specify the size of the container, or the size which the maximum size which you want to receive. So we'll just say size of recv server, and the last argument you just simply set it to 0, right? Now what we'll do is we'll simply spawn up a shell, but first of all what I'll do is I'll actually um, um, or anyways, let's just spawn up a shell now. So now is a part where things might get complicated, but don't worry, I'll try my best to explain you it in an easy way, right? So now what we are going to do is we are actually going to be using a function from the Windows API known as create process to actually spawn up command prompt. And then what we are going to be doing is we are actually going to pipe standard input, standard output, and standard error uh, to our socket. Okay, so we can actually see everything, what errors do we get, or what output do we get of the command which we execute. Okay, and we can also send the input. So for spawning up a process, we actually have to specify um, two structures, which is startup info and the process information structure. So I'll just say startup info and the process information structure, and I also have to give them names. So I'll just name startup info as SI and process information as PI. Whoops. Okay. I don't know why it just shut down itself. Sorry for that, guys. I'll just restart my VM and get back to you. Alright, so my Windows VM, for some reason it just went off, it just shut down. I don't know why, but anyways, it's up now. So let's get back to the programming part. So now what we'll do is we'll actually now specify the CB member of the startup infrastructure, which basically means the size of the startup infrastructure. So I'll just say si.cb is equals to size of the startup infrastructure. All right, and then what we do is we actually specify the DW flags member of the of the startup infrastructure. So I'll just say si.dw flags equals to now the flag which we specify over here. It's basically going to be start f underscore use std handles, and we are going to be using the start f underscore use show window. All right, now if you actually just go back to Google and just look at the syntax of this function, you'll find all sorts of information over here. So as you can see, the DW flags member is present over here, and the parameter which we and the argument, sorry for that, the argument which we pass to this function is start f underscore use standard handles, which is actually used for the standard input, output, and error. And we pass the start f underscore use show window argument, which basically is the w show window member. Okay, and the description over here says the w show window member contains additional information. So if you go back, now what we are going to be doing is we'll just say we actually pipe the standard input, standard output, and standard error to our socket. So let's just say si dot hstd input equals to si dot hstd output equals to si dot std input. Whoops, not input, actually error. And we are simply going to be piping this. Okay, we'll just pass this as a handle, okay, to our socket. So to the socket descriptor, which is shell over here. All right. And now what we do is we actually use the create process API to actually spawn CMD. So we'll just say create process, and the first argument, okay, it simply stays null. All right, and the second argument which we pass is the process which we want to spawn. So we'll just say cmd.exe, and the rest of the arguments are going to stay null. So I'll just say null, and the fifth argument, it's basically a boolean argument. Okay, so we'll just set it to true, and then we set the sixth one to 0 and the final ones to null. And finally we pass a pointer, okay, the address of the startup info structure and the process information structure. So I'll just say si and pi. Now if you actually have a look at the create process API, the documentation for that, if you just go to Google and if you just search up for create process MSDN, you'll find that you have the whole documentation over here and you have all of the parameters. So you can just have a look at it, and you can just understand about how this function is actually working. So if we go back, I'll leave up a comment over here saying create, or we can just say spawn command prompt, and I'll also leave up a comment over here saying pipe standard input, output, and error to the socket. All right, and now finally what we do is we just call the wait for single object function, which is simply going to start up our process. Okay, so we'll just say wait for single object, and we'll just say pi dot h process, and finally we set the last parameter to infinite, so infinite, and finally we close the handle. So I'll just say close handle, and we're going to be closing the handle of the process and the thread. So we'll just say close handle pi dot h process, and the thread, so pi dot h thread. All right, so now finally what we do is we're simply going to be we'll simply set the value of the recv data buffer to 0. So we are actually going to be using the memset function to do that. So I'll just say memset recv server, and I'll set the size of it to 0, and finally we specify the size of the array. So I'll just say size of recv server. Right, so now the reverse shell is ready, and what we can do is we can actually just test it out. But let me check if anything is left. I'll just delete the spaces up over here to just make it look clean. And okay, everything looks good, but yep, I actually forgot one thing, which is we also have to set the startup infrastructure to 0. Okay, so we'll just say memset, and what we'll do is we'll just say we'll just pass the address of the startup infrastructure, which is SI, and we'll just set this to 0. And finally, we just get the size of the startup infrastructure. Okay, so everything else looks good. Okay, so everything looks fine, but okay, first of all, sorry for that. I actually have to specify connection over here instead of connect. So I'll just set connection over here. And thirdly, we actually have to specify some additional libraries which we require, and also we have to set up a pragma comment. Okay, we basically specify a linker to the WinSock library. So first of all, we'll specify the WS2 TCP IP.h header file, and then we need the we actually have to set the pragma comment. We do not have to use the include statement for that, so I'll just say pragma comment lib ws2 underscore 32.lib, and that looks fine. Let's see what else do we have. uh, okay, whoops, we actually have to set up we need to type si.h standard input and h standard error. Sorry for that, my bad, it's a typo, so please do bear me with that. Alright, so everything else looks good. Let's just compile the script right away. So I'll use my standard CL compiler, the compiler which actually comes with Visual Studio. Okay, so I'll just say cl.exe, and I'll just specify the file name, which is revshell.cpp. And as you can see, it got compiled without any sorts of errors. So first of all, what I'll do is I'll actually go to Kali machine, okay, to my Kali machine, and I'll start listening for incoming connections on port 8081. So I'll just say nc-nvlp 8081, and I'll just go back to my Windows machine and execute the final executable. And once we go back, as you can see, we have a connection, and once we press any key, we get prompted with a command prompt shell over here. So now we can execute any sorts of commands. I can just navigate the directories. I can list out my network configuration. So as you can see, I have my IP address. So as you can see, we have a working reverse shell, and we can actually execute any sorts of command which we want. I can also execute the dir command, I can execute the whoami command, and so on. Alright, so as you can see, this works and there are no sorts of issues. And if we exit the connection, so if I just simply type up exit over here, as you can see, we get out of it, and if I go back to the Windows machine, our program also exits. So that's all for today's video. I hope you liked it. I know there were some mistakes from my side while coding, and I am really sorry for that. I apologize for that. And in the next video of the series, we're going to be having a look at how to utilize and abuse Windows API functions to actually execute our shell code and to gain a reverse shell. So with that being said, that's all for today's video. I hope you guys liked it. I'll see you guys in the next video.